I'm a huge fan of BattleBots, and I've always wanted to attend a college like WPI or MIT that has a BattleBots team. Until I get into those colleges though, I'm on my own. I was never able to get into actual BattleBots since those cost tens of thousands of dollars each. However, around my freshman year of high school, I was introduced to the NHRL while browsing YouTube. The Norwalk Havoc Robotics League, or the NHRL for short, is one of the largest combat robotics organizations in the world, hosting tournaments for 3, 12, and 30-pound robots as opposed to the 250-pound BattleBots as seen on the TV show. These events are streamed online and culminate in a world championship. Essentially, it opened a whole new world of different weight classes to me, in which I could make a BattleBot. I originally intended to make a 3-pound robot as seen in the NHRL's lowest class, but the skill cap is very high due to the nature of the televised competition. The community wisely advised me to enter either the 1-pound Antweight or plastic Antweight classes. For the sake of materials costs and simplicity, I chose the 1-pound plastic Antweight class. True to its name, the 1-pound combat robot class states that your robot cannot weigh over 1 pound, or around 450 grams. However, an additional limitation of the plastic Antweight class is that you can only use specific plastics, mostly those that are 3D printable for your robot, which provides an additional engineering challenge. Because of the materials limitations, the cost per bot is significantly lower than the full combat classes, meaning it's an excellent entry point for beginners in the sport. As all good designs start, I began sketching my design's major profiles on paper. Mostly these were in my class notebooks in between notes or exercises. I settled on a quite simple and effective design pretty quickly, which was a drum spinner with 2-wheel drive. I wanted the drum to be the full length of the robot and be rather massive to maximize kinetic energy. Additionally, I wanted to reuse the simple yet successful 2-wheel drive of my first robot, as it worked perfectly fine and I had no need to change anything. With my design settled on paper, I began to CAD my robot. The robot went through multiple iterations throughout the design process. The earliest one I captured with the version in Onshape was my first finished version, which I felt couldn't be updated any further without major geometry changes. This robot has a massive 120mm long, 150-gram drum with a continuous tooth asymmetrical design. The robot ended up being around 50 grams overweight, and I went back to the drawing board for version 2. V2 redid the major geometries with the addition of a discontinuous asymmetrical drum. What makes the split drum special is that the impact tooth has no counterweight behind it to knock the other robots away before the tooth engages, because the counterweights are moved over to the sides. This leads to a more efficient transfer of energy between the drum and the opponent at the cost of a lower tooth area. The V2 and V3 designs were very similar except for minor geometry changes, which allowed me to optimize my weight distribution and strengthen components. V4 strengthened the uprights and optimized for low mass, high strength parts, lowering infill to 60%. However, V5 lowered the infill to 15% with 3 additional walls, increasing the drum length back to 119mm while maintaining appropriate strength. This is where the robot stands, although I expect the design to change after test prints. For materials, I went with a tried and true PLA Plus 2.0 from Sunlu. The filament is very cheap and held up very well in my first competition when I used it for the spinner. All parts were printed at 15% infill with 6 walls to maximize strength to weight ratio, except for the drum, which was printed at 100% infill. The robot was christened Biohazard, and I extruded a single layer of light bluish-green filament in a Biohazard symbol on the top to add a bit of flair. Overall, the robot looks quite nice, and I am very happy with the finished result. This is where the project stands. Next step for me are to print some prototypes to verify tolerances and start assembling the robot. After I verify everything, I'll begin printing and assembling the final robot. Currently, I'm looking to compete in November, so an update will come sometime between now and then. Thank you for watching. I hope you enjoyed the video. Have a nice day.